See the whole thing? So this would be about the hardest drawing you can get. So if I zoom in, well, first of all, how many stories is this drawing?
Five stories?
Yeah, it says 5 stories on it right there, right? So I'm going to use my annotate here. So it says 5 stories right there. So it's a 5-story building. So once it says 5 stories, what comes in mind plumbing wise from third year?
Vent stacks?
Yeah, there's got to be a vent stack on here. Now this is a really fancy vent stack. It has to have a vent stack because if you have 5 stories with fixtures draining from them. So here we count it. Here's fixtures on this floor, on this floor, and this floor, and this floor, and that's 5 stories. So you need a vent stack. So the first thing here is, where is the vent stack? This would be the hardest drawing you'd ever get. And you're going to get it easier on the midterm. So let's go hard first. Where do you think, well, what's the rules of a vent stack? The vent stack is tied in where to the stack?
At the base of the stack.
At the base of the stack. Very good, Ruben. So let's go to the bottom, to the first floor. And there you're going to see, here is the, look at the stack is really funky, isn't it? It goes up and then you put, it's a big offset in the stack. Then it goes up again, another offset in the stack, and then goes to the top. So the vent stack has to tie in somewhere, or has to tie in the bottom, right? So at or below the lowest connection. So that means the vent stack is either going to be this pipe that zigzags all the way up. Oh, look at that, it doesn't even, goes up separately. Or it's going to be this pipe. One of these 2 pipes is going to be the vent stack. Which one would you think would be the vent stack?
B. I can't see the bottom.
The one that's at the end of the circuit vent?
Well, this is, can you see this right here, the bottom here?
Oh, yeah.
Okay, so it's either going to be this pipe here or this pipe here. So what are the rules?
I'd say it's A. A because E, or this one over here is a circuit vent. So I'd say A because that ties in above and comes out.
Well, you're right, but for the wrong reasons. But you are right.
Okay.
So what do we remember about vent stacks? How many fixture units can you dump into the base of the stack from a vent stack?
8.
8.
8. So what's it say here? It says 2-headed showers here. I'll put on my other glasses. 2-headed showers here and 5-headed showers here. So this says 5-headed showers. This says 2-headed showers. So if you look at table 2493, how many fixture units is a 5-headed shower?
6.
I think it's 6. Are you reading it right from?
Yeah, 6.
And how much is a 2-headed shower? 3 fixture units, right? Well, look how many. We obviously have exceeded 8 fixture units from this branch. So there's no way in the world this could be the vent stack, right? Because you can only dump 8 fixtures. Now, if you look to the left here, this is a little funky. It's got a lavatory. So on old drawings, unless otherwise denoted, lavs are always going to be 1 fixture unit or 1.25 inches. So that's 1 fixture unit. And this one right here, it says 0.09 liters per second dumping into this trap. What could that possibly be? It's a P-trap. And it says there's something dumping into it that goes 0.09 liters per second.
Is that an air conditioning unit?
Yeah, that's an AC unit that's dumping into a trap. So we look at 2410.3, right? And remember that number that we multiply to get a fixed unit load by liters per second? 2410.3 subsection 1 would be how you find the answer to this one. So 2410.3 subsection 1, subsection 1 tells you what?
31.7.
So you take the 0.09 here and multiply it times 31.7 to find out your fixed unit load dumping through that trap. So what is that? 31.7 times 0.09.
2.8.
Yeah, so it's 2.8. So this would be 3 fixture units. So that's 3 fixture units, and this is 1 fixture unit. So that's only 4 fixture units. That's under 8 fixture units. That's where your vent stack starts. We get it where I did that? That'd be the hardest drawing you would ever come across to figure out. So now that we know where the vent stack starts, typically the vent stack goes, it can go up independently, but typically the vent stack takes care of the whole drawing. But in this case, it hasn't. It's gone up separately and goes through the roof. And then we just have a branch vent taking care of these floors. Is that legal? Yes, it is. It's funky and it's different, but it is legal. What is the purpose of a vent stack? The main purpose of
At the bottom of the stack.
Say again, louder. Ruben?
To relieve pressure at the bottom of the stack.
That's right. That's its main purpose, and it still is fulfilling this purpose. It is still relieving pressure at the base of the stack. Now, how do you size a vent stack?
From its last connection to outside? Or from its lowest connection to outside?
Well, this is where it is. So this vent stack starts right here. You're thinking of the developed length of a vent stack, which we can do right now too. What is the developed length of a vent stack? Well, you just look at 2584 in your code book, right before or after table 2584, and it'll tell you the developed length of the vent stack is the exact same thing as the developed length of a stack vent. And it's pretty easy. It's the shortest developed length in words. And what is it? Anyone know?
Lower end to outside air.
Lower end to outside air. So in this drawing, if you look where we dump these fixture units in, there is the lower end of this vent stack, including the wet part. So I'm going to go up and you're going to you guys tell me where it ends. Well, outside air, there's the developed length of that vent stack. You'd have to count the 15 meters, the 4 meters, the 3 meters, the 5 meters, and 5 meters, all the way down to the bottom. That would be its developed length. So yes, the developed length of a vent stack is lower end outside air. Now, so is a stack vent. But on a stack vent, the stack vent's way up here, isn't it? This is the stack vent. It's lower end from outside air too, but see how short its developed length will be. Completely different. So how do you size it? Well, you need the developed length. You need to know the size of the base of the stack. So way down here. So you basically have to count all the fixture units in this building or count how many toilets are dumping into the stack to size the base. Is there 3? Well, you'd have to have how many toilets to dump into a stack before it turns into 4-inch?
2.
2492 subsection 3. 2492 subsection 3. How many toilets that make the stack 4-inch?
Is it 6?
Well, more than 6, right? 6 for 3-inch, 7 toilets for a 4-inch stack. So if you didn't want to count all the fixture units, you just count the toilets. Well, there's not 7 toilets on this drawing, is there? There's only 1 here. There's a toilet. There's a toilet. Here's another toilet. Is there any more toilets? I don't think so. There's only 3 toilets. So that means the branch or the building drain down here has to be 4-inch. According to 2492 subsection 2, every branch or building drain is 4-inch with downstream of the third water closet, but the stack doesn't have to be 4-inch. So what would be the biggest load to make this stack 4-inch? Well, let's look at table 2410-6A. 2410-6A. That's the soiler waste stack table. So on the soiler waste stack table, you've got 3 columns. The column on the right, the farthest on the right, is from any 1 story. Can everyone see that? From any 1 story on the soiler waste. So I want to look at, and if you look at any 1 story, if you exceed 18 fixture units, exceed it, that stack is going to be, from any 1 story, is going to be 4-inch below there, right? More than 18 fixture units, so more than, is going to equal a 4-inch stack. So look at your stories on this drawing and see, do we have a story that has more than 18 fixture units? Well, right down here, this is probably going to have the most, isn't it? Because these 5-headed showers are 6 fixture units each. So if I go 5 times 6, that's 30 fixture units. So below this branch right here, this vertical stack has to be 4 inches right there. 4 inches. So that's going to tell us something too. So we know the stack is 4 inches. I want to size the vent stack. So I already know that I have to look at the base of the stack. So open up to table 2584. 2584. That's the stack vent stack table. We're sizing the vent stack right now. So we need to know the base of the stack. So look at 4 inch on table 2584, and because we know it's 4 inch, but you need to know the whole fixture unit load draining to the base of that stack. Now on this one, I think I just remember, I think there's 88 fixture units. So instead of counting them all up, I'm going to go 88 FUs. So 88 FUs you need to use 4 inches, right? What else do you need to know? You need to know the developed length of the vent stack, don't you? So you got to count from here, from number 24 all the way to the top. So let's count that up. 5 meters, 10 meters, and plus 7, 17 meters, and 15 meters is 32 meters. There's your developed length. So using these 3 numbers right here, look at table 2584 and tell me what's the size of that vent stack.
3 inch.
3 inch. See, that's the long, hard way to size a vent stack. Now I'm going to give you the easy way. The easy way is on any building that's 5 stories, and obviously it's going to have a certain load of fixture units, 95% of the time, it'll be a 3 inch vent stack. So even if you forget what I just showed you, on a drawing, if it's a 5-story building, it's 95% chance it's going to have a 3 inch vent stack. Most vent stacks out in the field are 3 inches because of load and developed length. And why? Well, the stack vent could be smaller. It's because of the developed length. The developed length goes from here all the way up. It's got such a large or long developed length of 32 meters. It's going to typically make that vent stack 3 inches. Now, if we did the exact same thing on this drawing, we said, okay, I don't want you to size the vent stack. I want you to size the stack vent. So the stack vent's up here. So the stack vent, we look at the same table. It's got all the same code clauses. The only thing, and it's going to have the same load. How do you count the fixture unit load for a vent stack or a stack vent? You count all the fixture units that drain to the base of the stack it's serving or any vent attached to it. Now, in this case, the vent stack used the total load because everything's draining to the base of the stack. Even though this vent, not all these vents are attached to it, the whole load is going to it. It's either or reason. You count the total fixture unit load to the base of the stack and or any vent attached to it. So if I want to size the stack vent, I'm going to use 88 fixtures again. I'm going to use the base of the stack is 4 inches. The only difference is this one right here. We're not going to use 32 meters for the stack vent. What are we going to use? Well, the lower end is from here to here for the stack vent. So the meters is going to be a lot lower. So what is it? 3 meters and 2 meters. Only 5 meters is the developed length for the stack vent. So what would be the minimum size of the stack vent in this drawing if you used 88 fixture units, 4 inches, and only 5 meters of developed length?
2 inch?
It's only 2 inch. And that's what it would be as an answer on the drawing. So why? Because I only need 1 3 inch vent in the whole building. I already got my main 3 inch vent. It's this vent stack here. So the vent stack here is 3 inches, 3 inch vent stack, right? And the stack vent right here, this one right here, is only a 2 inch stack vent. That's it. Now this stack vent is going to meet this branch vent. What's it going to end up being as it goes out? Stack vent meets branch vent. Who wins?
Stack vent.
Stack vent.
Stack
Stack
vent.
vent.
So on this drawing, this is going to stay a stack vent, right? Now over here, this vent stack, did it meet another stack vent? Sorry, I'm on the wrong one. This is the rainwater leader. This is the stack vent here, or the vent stack here. Does this vent stack meet another stack vent or a vent stack? That's the only way it could become a vent header. No, it doesn't. It just meets branch vents. So this will stay a 3-inch vent stack out of here, and this will be a 2-inch stack vent here. There'll be no header on this drawing because they don't join together.
So, sorry, a vent header is when either one of those two come together, it immediately becomes a vent header?
A vent header, so here's a vent header, equals a stack vent plus another stack vent, or a stack vent plus another vent stack, or any combination of, right? So if they don't join together, there's no vent header on this drawing. And on this drawing, this is a vent stack here, and this is a 2-inch over here stack vent, and this is a 2-inch stack vent here. They don't meet, so there's no vent header if I join them together. So what's joining together on this stack vent? Well, what's this called? Well, that is the stack vent. So let's just look at it. What's T? What would be this? I'll just circle them. What do we call this? Well, what's it coming off of? What's this here?
A bathroom group?
Yeah, it's just, so that's a what?
Individual vent?
Not individual, because it's serving 3 fixtures.
Individual continuous.
Yeah.
Not individual and continuous, it's just continuous, because it's the continuous vent serving this wet vent for these 3 fixtures, right? And notice here how, the only thing I don't like about these drawings is they don't show Ys and 45s. This Visio drawing is from BCIT originally, years ago. And notice how he's doing his wet vent? That's a symmetrical Y, it's not a cross T. It's supposed to be, and he ran straight to the toilet. Works perfect, right? Bathtub on this side, vanity on this side, wet vent here, continuous vent here. So that's a continuous vent. Well, what's this? This is another, this is only a 2-piece bathroom, right? Toilet here being wet vented through the lav. And so this is another continuous vent. Continuous vent meets continuous vent. What would V be?
Branch?
That's just a branch vent, right? So branch vent meets vent stack. It doesn't become a vent header. It stays a vent stack, right? Or stack vent, sorry. So this, this is a branch vent. I have to start at the bottom for this to make sense. So we're going to go right to the bottom here. Notice how this vent goes over here. So all these vents join together, and what would S be?
Branch.
A branch vent. So this is a branch vent, and this is a branch vent. They join together, they're still a branch vent. They don't become a stack vent until they hit the stack vent up here. So that's all branch vents there. So what are all these? Some of you named them before. Look, isn't this one the same as this one, the same as this one, same as this one, same as, what are they?
Individual and continuous?
They're all individual and continuous vents, right? Now, I could have circuit vented these. You don't just circuit vent floor mounted fixtures. You can circuit vent above ground fixtures. How would I circuit vent it? If I wanted to circuit vent it, then I would basically go like this and run a circuit vented branch at this height, and I'd Y all of these in like this. I'd Y these traps in, and then I could have a circuit vent here, and then it'd be a circuit vent at the beginning and a relief vent at the end. I could have done that, but if they're all vertically taken up, they're all going to be individually and continuous vented, right? So that's a branch vent, and then it meets a stack vent, and then it's a stack vent. Now here, this vent stack, this is going from here, and it's still relieving pressure at the base of the stack. It just didn't tie in there. Normally, we tie all of these branch vents into the vent stack, but you don't have to, right? So I don't even have a circuit. Oh, I do have a circuit vent on this drawing, don't I? It's down here. Oops, let me get a circle going on here. So here's our circuit vent right here. Now, what would be this vent in the middle?
Additional relief vent?
That would be an additional circuit vent. That would be an ACV, right? Because we have more than 8 traps between the circuit vent and the relief vent. So there's only one circuit vent on this whole drawing. These are all just little 3-piece wet vents and continuous vents, these 4 bathrooms. Oh, we have 4 bathrooms here, don't we? 4 toilets, right? And so downstream of the 4th toilet, that just means the branch and building drain has to be 4-inch. This is 4-inch just because of the soil waste stack. We don't have enough toilets to make it 4-inch. Does everyone see what I'm trying to do? This would be the hardest drawing you'd ever get, and you probably won't get a drawing like this. So let's go to a simpler drawing. I'm going to clear this. And, well, you could have seen it anyhow. So I'm going to go back into, hang on. I'm going to add a date here. And I'm going to go back into D2L. Here's D2L. Oh, can you see this or do I have to reshare? Can you see the drawing?
No.
No? Okay, let me reshare. Hang on a second. Okay, can you see it now?
Yep.
Okay, so we're going to go into content. Let's take a look at, and you can see, you're following, I'm going through the same, load more. I'm going to go into a different drawing. Now what I'm going to do here is, that was Combi drawing number 5 we were just looking at. And here I'm going to put the answer key up here, so make visible. And this will tell you the answers to all of them. So you can look at that if you want to study it, but you don't have to know anything this hard. I'm going to go over something that would be typical of what we're going to see. This is what they would have. Oh, I'm almost running out of time, so I'm going to get right to the bottom here. I'm going to go right to the bottom and see how it says Complete National Plumbing Code Package. We're going to look at that. I'm going to cherry pick a drawing here and you tell me. And all you're going to have to do on the midterm is identify pipes. You're not going to have to size them. That's for the final we'll do. So for the midterm here, I'm going to look at page, I'm looking for page 81. Did you get all that? Can you memorize that? So here's another one here. Identification drawing number 3. Okay, so if I look at this, what's wrong here? What is that and what's wrong with it?
You need an ACV.
Yeah, you need an ACV in the middle. That's what's missing. That's a circuit vented branch, right? With a bunch of shower heads, 1.5 inch shower heads. And really, that's the only circuit vent on this drawing. You have these 2 showers are being wet vented through the 2 lavs. Here's a bunch of individual and continuous vents and some continuous vents. Not really too much to this one. I'll just point to it. What do you think I is? Or number 1, I mean. Here's number 1 right here. What do you think that pipe is?
Stack then.
Stack.
That,
That's a stack because it's going through more than 1 story, right? And so what's happening? This is a 2-inch floor drain down here.
Acting as a multi-story wet vent, or?
Yeah, this 2-inch floor drain, because it's under 3-inch, has to be wet, has to have a vent. So it's being wet vented through this kitchen sink. So this is a wet vented waste stack, and the 2-inch floor drain is being wet vented through. So what will be the top of the wet vented stack?
Stock vent.
That would be a stack vent right there, right? Fairly easy. So let's go. Is this a 5-story building with fixtures draining from 5 stories?
Hell yeah.
1, 2, 3, 4, 5 stories. So we need a vent stack. So where's the vent stack?
E?
Yeah, that's the vent stack right here. So it would be creepy crawling down here all the way up. And the vent stack is still a vent stack. That's a continuous vent tied to it. Still going to be a vent stack. Oh, these are branch. This is going to be a branch vent K. So this is branch vent meets vent stack. Vent stack still more important. So the vent stack will continue on. These little vents aren't big enough to change it. It's still a vent stack. And then if I go over here, let me scroll down. Oh, now I lost it. Ah, there we go. Right here I was. So I'm just going to go up a little bit. And where my vent stack is here. I got to go up a little more. So I'm going to get rid of these circles. So here's my vent stack. The vent stack is S. It keeps going up. And what does it hit? What do we just call Q?
Stack vent.
So there it is. Vent stack meets stack vent. What would T be?
Vent header.
And
Vent
T
header.
then is a vent header. Because we have a vent stack, so we're right down here. This Q is a stack vent. Boom. And S over here is a vent stack, right? And T is now going to be a header, right? And that means header is the ace of all vents. There's nothing higher. That means Y and X are also going to be vent headers. Nothing will beat that right till outside air. So if I said, what is the developed length of a vent stack on this drawing, on this vent stack, you would go all the way to the bottom to the lower end. You'd creepy crawl all the way up here, all the way to there's the, oh wait, what is the developed length of the vent stack? It's from lower end to outside air. So its developed length actually goes right to outside air. But where is the actual vent stack? Well, it's from lower end until Q, and then it becomes a vent header. So there is the actual vent stack, right? Sorry, here, boom, 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 boom. There's your vent stack, but its developed length goes right to outside air. You understand the difference? So on the midterm, I'm going to give you a drawing similar to this, and all you have to do is identify it. Identify what all the parts are. So D, what's D?
Continuous vent.
Continuous vent.
D is a continuous vent. You are correct. We already did one, right? It's a wet vented waste stack. What would be this vent right here, 10?
Dual continuous?
Dual continuous?
No,
Oh, it's only continuous. The one to the left is dual.
you're right. This
Continuous,
is
right?
only continuous. There's your mini wet vent, and there would be a branch underneath it. This right here, that would be dual and continuous, M, because it's rising off a vertical and serving two fixtures. J would be easy, individual and continuous. What would H be?
Continuous.
That would be continuous because there's a little mini wet vent underneath it and a branch. And of course, this would just be individual and continuous. If you join them all together, they're all branch vents until they meet F and E. F and E are vent stacks, right? It's still the same vent stack. So a vent stack ties in right here to a branch vent. Well, then it's gonna, vent stack wins. So vent stack will be here, all the way up until it hits a stack vent, and then it becomes a vent header. Right? Down here, what's B?
That's the circuit vent?
That is your circuit vent. B. What's A?
Relief vent.
Relief vent?
That's your relief vent on the downstream side. And of course, what we're missing on this drawing is something in the middle because there's more than 8 of them. So you'd put in the middle. And if I put that in the middle, what would be the name of this?
ACV.
That would be an ACV, right, in the middle. So there's your relief vent, there's your circuit vent, there's your ACV. What would this be called? Oh, we already know it's the vent stack, right? So let's go up to here. So let's follow the stack right from the base. And this is an offset in the stack. That's what 15 is. And so now we're going to, oh, what's this over here? Oh, that's that 2-inch drain. Oh, it's 2 inches under 3 inch, so it needs a vent. So we're going to wet vent it through this drinking fountain, right? And so if that's a wet vent, this is going to be a continuous vent. C is going to be a branch vent. Branch vent meets continuous vent, stays branch vent. So R would still be a branch vent, right? R is a branch vent. So now R goes up and it meets a vent stack and then it turns into a vent stack. So what did I not cover? We covered that one, We know that you can dump up to 8 fixture units into the base of the vent stack, and here we have a flush tank, toilet, and a lab. There's only 5 fixture units. That's how you identify where the vent stack is. And this is just an individual and continuous vent.
Would C be a branch vent?
C, A, B, C. C would be a branch vent, yes. Oops. Spell right here. Branch vent. That's C. Yeah. It's going to be a branch vent right until it meets the vent stack, and then it's going to turn into a vent stack. So if I want to follow the main stack, here is your vertical stack. By the way, what size would it be at the base of this stack? Would it be 3-inch or 4-inch?
4-inch.
4-inch.
Well, the only way it's going to be 4-inch if we exceed 18 fixture units on any story, or if there's 7 toilets tied to it. So how many fixture units are there here? Well, we've got 6, 9, what have we got? 12 or 13 inch and a half showers. I don't think that's 18 fixture units, is it? Do I have 18? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 1.5. That's 18. Not over 18. So that means there's not enough from all these fixtures to make, and that's not enough to make it over 3-inch. That's now the building drain, if it has 3 toilets, will be 4-inch, but the stack will not exceed 3-inch unless we exceed over 18 fixture units from any story, and we have 7 toilets. We don't have 7 toilets, so this stack is only 3-inch.
So is it a more than rule? Because if it's
More than 18. So 18, if you look at the soil waste stack table on the 3rd column, 2, 4, 10, 6A, it'll say 18 fixture units will, from any one story, it'll still be 3-inch. So you'd have to have 19 fixture units to go to 4-inch on the stack. Or 7 toilets. And I don't see 7 toilets on this drawing. So it's only got a 3-inch stack, unless it exceeds the fixture unit load from the middle column on the soil or waste stack. And I think you can put, everyone look at the soil or waste stack table. How many fixture units can you put into a 3-inch stack? Is it 102?
102.
So
Yep.
I'd have to exceed 102 fixture units. So this whole page would have to exceed 102 fixture units, which I know it doesn't. So that's still a 3-inch stack. So when you size this vent stack, you would have to use whatever the fixture unit load is, and it would be a 3-inch stack that you'd have to look at. So this one might be under 3-inch in size. You'd have to add it up. Any other questions on this drawing? So this soil or waste stack goes into the offset, it goes up here. And where is the stack vent on that main stack? Is it here or is it here? So this stack is what I just traced up here. This one here. Where is the stack vent? This one or this one?
The one on the right.
Yes, this is the stack vent. This is just a branch going into the stack. The stack vent is right here. So that's that main stack vent on the main stack of the building, right there. Right? So even if this stack vent wasn't here, this vent stack would have met this stack vent, and then this would have been a vent header anyhow. But as it is right now, the vent header starts at T and goes all the way up.
Hey, Freddie, can you just scroll down a smidge?
Okay, hang on. Oops,
Oh.
sorry.
Uh,
I'm gonna, hang on, I'll clear the drawing. So you want to see here?
yeah, I just wanted to see the end.
So this is 22 would be a branch or building drain. If I said it was the entire building on the drawing, this would be a building drain. And this, would this have to be 4-inch? Well, do we have 3 toilets on the drawing? There's 1, there's 2, and do I only have 2 toilets on here?
Yeah.
Oh, well, not enough to make that 4-inch. It'd only be the load. Oh, wait, how many fixture units can you dump into a 3-inch building drain? I think only 27, Daryl Sittler's number. So that would make it 4-inch just because of the load. Because I'm sure there's more than 27 fixed units going into it. See all the different rules you have to know. And we have run out of time, but identification number 4. I love this drawing. This would be a good drawing to study. I'm not going to tell you the answers on it, but it'd be a good drawing to study. Hint, because it shows quite a few different things on here. We have at least a 5-story building. We've got a multi-story wet vent. We got circuit fence, everything. That one would be a good drawing to study on page 181 of this setup. Okay? And that's all the help I'm going to give you for the midterm. So for now, so where do you find this? This is under that content. So this is where we are. We're under drawings, supplement, 3D, PowerPoints, and you have to keep loading, and it's right at the bottom. Go right to the bottom. It's number 28. Number 28, identification drawing number 4. I'll let you look that on your own, and you can discuss it, and that'll be good study prep for the midterm. Any other questions?
You say the midterm was on Wednesday?
Yes, it is. Wednesday. Tomorrow we have gas at 10 in the morning, and then we have at 12 water supply.
Okay.
It's gonna be during class though.
What do you mean? Oh yeah, you're gonna. No, I'm gonna open it up. I'll probably just let you write. We'll open up with class at 12, and I'll let you write, and then I'll probably leave it open until about 7 or 8 at night, so you have lots of time to write. Okay. So that's it for today. Try and get some cold, fresh air, and I'll see you tomorrow.
Thanks,
Thanks, Fred.
Okay.
Thanks, Brett.
Have a good one.
Bye, Brett.